Hey there, I have never before done a video to make a book review or a book recommendation, but I am doing it for this one because I absolutely loved this book. It's called Why Pie, as you can see here, and it is a terrific book. I'm going to be showing a little, some parts of the book that's legal under fair use for purposes of review or critique, or in this case for recommendation. This book is fantastic if you either love math or if you want to love math. Also, if you love history and the way that math interfaces with that, or if you're a parent and you want your kids to understand how math is relevant in everyday life, and even for yourself, just to appreciate the way the world works and the math that's behind so much of that. So let me show you a little bit of this book, Why Pie, and it's by someone by the name of Johnny Ball. I'll show you just a couple of key samples here just to give you a flavor. The book is very, very colorful, and it goes through sort of, everything that, thousands of years ago, or a lot of the things that thousands of years ago were figured out by, our ancestors in terms of everything from the phases of the moon and how they decided to, make that into a month, and, figuring out how long, how many days there were in a year, following the seasons, and how that was so important for agriculture, and just like the math behind how they figured out all of these different things with angles of the sun coming through rocks in places like Stonehenge, or figuring out how to make extremely straight lines so that they and mathematical preciseness so that they could build amazing things like the pyramids. How they could measure land for agriculture, and as you can see, for all of this, it has really just cool, bright colors. Short little vignettes, so that literally you could, read, 2-3 minutes and just read, half a page or something like that, and really you could put it down and come back to it later. Here showing about, how, the Babylonians, and then so much of the the fantastic work that was done by the Greeks thousands of years ago, figuring out. They loved triangles, and how you could use that information to make calculations about how far away something was, and they could even calculate, thousands of years ago, how far away the moon was, just using triangulation and terrific, cool stuff like that that laid the groundwork for, basically inventing trigonometry. Here I'll share just one vignette here. This was the story of Aristophanes, who was in Alexandria in modern-day Egypt, and part of the Greek Empire at the time, a couple hundred years BC. And he heard this story about a place called Syene, where one day out of the year, what would actually be nowadays, would be June 21st, the sun, shone directly up from a well. That light from the sun came reflecting straight up the well, only on that one day out of the year. And the columns in that town, in Syene, had cast no shadow immediately at noon on that day. And Aristophanes, said, "Well, boy, I'm here in, I'm not in, Syene, but I'm back here in Alexandria, and on that same day of the year, boy, nothing, happens here, or rather our towers and such still have a shadow." And he figured, well, why would that be? And he actually came up with the idea that the sun is, immediately, overhead to Syene on that one day per year, when the sun is, that far up, on the latitude, to be directly overhead, and then he figured out, well, it's not directly overhead at that day where I am in Alexandria, a little further north. And he, made a tower, and he said, boy, it doesn't seem to, give me that shadowless day or that shadowless noontime. I have a little bit of a shadow. And the Greeks, since they were so fantastic with trigonometry and angles and triangles, he figured out that it was about 7.2 degrees that the sun, had a difference in angle compared to where he was versus Syene. He actually paid somebody to walk and the distance between the two towns, figure out how far it was, and then do the math to calculate how 7.2 degrees turned out to be 800 kilometers, about 500 miles. And he said, "Wow, if my theory is right, that this is that this difference in the shadow is because we're on a curved surface on this Earth that we're on." He figured out that if the whole thing was a sphere, that the distance all the way around, the circumference of the Earth, would be about, here, 40,000 kilometers, which is about 25,000 miles. And sure shooting, he got it right within a couple of percentiles. So amazing, things like this, that little vignettes that are really fascinating and well explained, and that's just one, for example. I mean, it's just filled with them, page after page of colorful stories from everything from building the Roman Colosseum to to the amazing precision of the Roman aqueducts. To measuring all kinds of things and ratios and human body and sundials, and how do you figure out the time based on shadows of the sun or by looking at the stars. All these kinds of just really cool stories. Everything from figuring out mathematically, how did they figure out mathematically that the sun was in the center and that the planets went around it. So everything from folks like Copernicus and Kepler and eventually Galileo, that basically we're figuring these things out using mathematics. So figuring out distances at sea, and guiding yourself by the stars, and just the basic math behind it, that once you read this, you're like, wow, that is amazing that they figured it out. And so cool that that this is part of our history, and would be a shame for it to be forgotten. And here, just presented in such a colorful, delightful, entertaining fashion. And then coming up to modern day things like electricity, and looking at light, and the speed of light, and and pressure, and sound waves, and music, and the mathematics behind music, and all kinds of things along these lines. Modern disasters, hurricanes, tornadoes, earthquakes. How do we use math to measure all of these things? Or measuring things that are really super duper big, like the distance to the sun, or things that are super duper small, like nanoparticles. Just everything in the world around us, and how mathematics figures into our understanding of the world that we live in. So again, just obviously I loved this book. I actually, as a parent, got this book for my son. He was 9 years old at the time, and thought, this will be a great book for him. And really, yes, he loved it, but I think I loved it even more myself. Maybe as a bit of a science geek or what have you. But I think just terrific book. I would highly suggest it for folks of all ages, actually. Just a really cool book. Check it out at your local library. Buy it. Give it as a gift. Whatever. I don't get a commission for this. I just really loved this book, and hopefully you will too. So, Why Pie by Johnny Ball. Check it out. It's awesome. Bye-bye.